Good morning, students. Welcome to our physics class. In the previous classes, we discussed a new chapter called Gravitation. We know all objects in the universe attracts each other with a force. That force is called gravitational force. Okay, then what is universal law of gravitation? Universal law of gravitation states that every objects in the universe attracts each other with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between them. Why this law is called universal law? Yes, this law is applicable to all objects in the universe. That's why this law is called Newton's universal law of gravitation. Okay, this law holds us to the earth. This law helps for the motion of the planets around the sun. The tides are due to the attraction of the earth on the moon. All these examples are related with the universal law of gravitation. Okay. In the previous chapter, we discussed three equations of motions. What are the three equations of motions? Number one, V equal to U plus AT. Second, S equal to UT plus half AT square. Third equation, V square equal to U square plus 2AS. Okay. Then in the chapter force and laws of motions, we discussed three laws of motions. Okay. First law, every objects continues in a state of rest or of motion in a straight line unless compelled by an external force to act otherwise. What is second law? Rate of change of momentum is directly proportional to the applied external force, F equal to ma. What is third law? To every action there is equal and opposite reaction. Okay. Using these concepts, we can explain a new term called free fall. Next term is free fall. What is the meaning of free fall? Okay, we know, for example, if this chalk is dropped from a height, what happens? This chalk falls towards the earth due to the attraction of the earth. Okay, this type of fall is called free fall. Okay, if an object is dropped from a height, it falls towards the earth due to gravitational force alone. So we can say this the motion of this chalk is under free fall. Okay, so what is the condition of the free fall? Okay, if an object falls towards the earth, if it is due to the acceleration due to gravity, or it is due to the attraction of the earth, or it is due to the force of gravity alone, so we can say this chalk is under free fall. Okay, then we know in the case of free fall, or in the case of falling of an object under the influence of gravity, there is velocity. Okay, so there may be change in velocity, so there is an acceleration in the case of free fall. Such type of acceleration is called acceleration due to gravity. So next term is acceleration due to gravity. This acceleration due to gravity is represented by a letter, small letter g. Acceleration due to gravity is denoted by a letter g. So, what is free fall? Free fall is the fall under the influence of gravity alone. Fall under the influence of gravity of earth alone. This type of fall is called free fall. In the case of free fall, there is change in velocity, so that means there is an acceleration. So acceleration under the gravity of earth is called acceleration due to gravity. It is represented by a letter g. Clear? Then we can find an expression for acceleration due to gravity. We discussed Newton's second law. What is Newton's second law of motion? Newton's second law of motion states that rate of change of momentum is directly proportional to the applied external force. Okay, using this second law of motion, we can explain an equation to find force. What is the equation to find force? Yes, what? F equal to m. F equal to m. Okay. Then in the case of free fall, A equal to G. In the case of free fall, we can write F equal to mg. This is the equation to find force in the case of free fall. We know in the case of free fall, acceleration, there is acceleration. That acceleration is under the influence of gravity, or that acceleration is the due to the attraction of the earth. That's why we can write A equal to G. So this equation changes to F equal to mg. What is F? Force. M, mass of the object. G, acceleration due to gravity. Clear? Okay. Then we know what is the equation of universal law of gravitation. What is universal law of gravitation? Every object in the universe attracts each other with a force, which is directly proportional to product of their masses and inversely proportional to square of the distance between them. So we can write F equal to G mm by d square. This is equation number 2. F equal to G mm by d square. F, force between two objects. G, gravitational constant. Capital letter M and small letter m, masses of the objects. D, distance between two masses. Okay. So, comparing this equation 1 and 2, we get a new equation. Comparing equation 1 and 2, we get, what is the value of F? F equal to mg. So we get mg equal to G mm by d square. On both sides, small letter m cancels. So we get G equal to Gm by d square. G equal to acceleration due to gravity. G equal to gm by d square. Okay. If object is placed on the surface of the earth, if the object is placed on the surface of the earth, we can write d equal to r. R means radius of the earth. Okay, so we consider earth. Okay, this is the center of the earth. This is called radius of the earth. If the object is placed here, here is the object of mass m. Object of mass m is placed on the surface of the earth. We can write d equal to r. R means radius of the earth. So this equation changes to, therefore g equal to gm by r square. This is the equation to find acceleration due to gravity. Acceleration due to gravity, g equal to gm by r square, where g, gravitational constant, gravitational constant, m, mass of earth, r, radius of earth. Okay, so this is the equation to find acceleration due to gravity. This derivation is very important. Okay, so how we can derive this acceleration due to gravity? So from the Newton's second law of motion, we get F equal to ma. In the case of free fall, a equal to acceleration due to gravity. So replace a by g. So F equal to mg, equation number 1. Second, by the definition of universal of gravitation, we get equation number 2. Then comparing equation 1 and 2, we get g equal to gm by d square. If the object is placed on the surface of the earth, d is replaced by radius of the earth. So d equal to r. So this equation changes to g equals gm by r square. So where g is the gravitational constant, m mass of the earth, r radius of the earth. Okay, so from this equation we clear that acceleration due to gravity is independent of the mass of the object. What? Acceleration due to gravity is independent of the mass of the object. Acceleration due to gravity depends mass of the earth and radius of the earth. Okay, so what are the factors which depends on acceleration due to gravity? Acceleration due to gravity depends on mass of the earth and radius of the earth. This acceleration due to gravity is independent of the mass of the objects. Okay, this acceleration due to gravity is represented by a letter g. Then what is the unit of g? G means acceleration due to gravity. It is acceleration due to gravity is the acceleration under the influence of gravity. So we can write the SI unit of acceleration due to gravity, or g is meter per second square. Unit of acceleration due to gravity is meter per second square. Clear? Okay, so this is about free fall and acceleration due to gravity. Okay, next we can find the value of acceleration due to gravity using the given data. So here, what is the value of universal gravitational constant G equal to 6.673 into 10 raised to minus 11 Newton meter square by kg square. What is the mass of the earth? M equal to 6 into 10 raised to 24 kg. Radius of the earth 6.4 into 10 raised to 6 meter. Using this data, we can find the value of acceleration due to gravity using this equation. G equal to Gm by r square equal to, substitute these values in this equation. What is G? 6.673 into 10 raised to minus 11 into mass of the earth 6 into 10 raised to 24 kg divided by r square. R 6.4 into 10 raised to 6 whole square. Okay. On solving this equation or on solving these values, we get the answer is 9.8 meter per second square. So, what is the value of acceleration due to gravity? G, 9.8 meter per second square. Clear? Okay, so substituting these values in the given equation, we get 9.8. So we know what are the factors which depends on acceleration due to gravity. Acceleration due to gravity depends, number 1, mass of the earth, next radius of the earth. Acceleration due to gravity is independent of the mass of the objects. So all objects in the free fall falls towards the earth under the acceleration due to gravity of 9.8 meter per second square. Clear? Okay. Then this acceleration due to gravity is constant everywhere in the universe? No. Acceleration due to gravity changes from place to place. Acceleration due to gravity of the earth changes from place to place. Okay, so we can explain. We consider earth. This line is called equatorial line. This is equatorial line. This point is called pole, north pole and south pole. Okay, so equatorial lines and poles. Okay, in the case of equatorial lines, radius is large as compared to poles. So this is the radius of the earth, r. Radius of the earth is greater than in equatorial than at polar regions. Okay, so this r is large. Okay, so equatorial line. Equatorial line, radius is large. So acceleration due to gravity small compared to poles. So this is the equation. G equal to Gm by r square. Okay, why? G is inversely proportional to r square. G is inversely proportional to square of the radius. Inversely proportional means r increases, G decreases. R decreases, G increases. So, in the equatorial line, radius of the earth is large as compared the radius at the poles. So, G is small. Okay. So, at the poles, R is small compared to equatorial line. Okay. So, G is large. Why G is large? Acceleration due to gravity is inversely proportional to the square of the radius of the earth. So, acceleration due to gravity is not constant everywhere in the earth. It varies from equatorial lines to poles. Okay. Then at the center, of the earth, what is the value of r? R equal to 0. Therefore, G equal to 0. At the center of the earth, G equal to 0. At the poles, G is large compared at the equatorial lines. At the equatorial lines, G is small as compared at the poles. So, G varies from place to place. So, this is about acceleration due to gravity. What is acceleration due to gravity? Yes, acceleration due to gravity is the acceleration in the case of free fall. What is the meaning of free fall? Free fall means falls under the influence of gravity alone, that is called free fall. In the case of free fall, what is the value of G? What is the value of acceleration due to gravity? G equal to Gm by r square. Okay, what is the value of acceleration due to gravity? 9.8 meter per second square. Okay, at the equatorial line, poles and at the center of the earth, the value of acceleration due to gravity varies. Clear? This is about acceleration due to gravity. Okay, so today we can conclude our class.